In example number 10, you can see that I now have a division sign. Now you need to make sure that you understand how you can change that division sign to a time sign. So long as you have a common numerator over a denominator after the division sign, you can change that by changing your sign to times and tipping the fraction after. But I'm not going to do that first. I'm first of all going to go back and I'm going to see what can I factorize so that I can cancel common factors. The reason why I chose this process rather than finding an LCD is that the signs between my fractions are times and divide, which means that I already just have factors. So what I'm going to do in turn is I'm going to take a look at each numerator and each denominator factor and see how I can simplify it by factorizing. So starting at the beginning, if I've got 2x squared minus 7x plus 6, that is going to be able to be factorized using the trinomial method. This sum is also crammed with trinomial factorizing. Now, trinomial factorizing is all very easy when your coefficient of x squared is a 1. But at the moment I put a number other than 1 next to x squared, it becomes a little bit more demanding. In order for us to understand this process well, I'm going to do each one of these trinomial factorizings in full without just writing down the answer. Now, the way that I do this is that I first identify what kind of sum I'm going to have. In the first numerator of 2x squared minus 7x plus 6, my last sign is a plus. It means that when I'm working out my middle term, I must add. The next thing that I do is I draw my trinomial cross. Onto my trinomial cross, I write down the first coefficient and the last coefficient as factors. The 2 comes at the front, so I'm going to write 2 and 1, because 2 times 1 is 2, and I split that at the front of my cross. The 6 comes at the back of my cross. Now, because 6 can be written as 1 times 6 or 2 times 3, I have to think a little bit harder. I want to write down a number so that when I add the numbers together, I'm going to get a 7. If I write a 2 here and a 3 there, and I add these numbers once I've cross-multiplied, I'm going to get a 7. But I don't want just a 7, I want a minus 7. So I'm going to be adding minus numbers, which means that I must have minus 3 added to minus 4. All that remains is for me to fill in the x's. And just like you do with the difference of two squares, we're going to split our x's, one in the first bracket and one in the second bracket. The way you read this off is the top line is your first bracket and the bottom line is the second bracket. So the first numerator, factorized into linear factors, is going to be 2x minus 3, all times by x minus 2. Now going through all of the others, I'm going to do the same process, but I'm going to still do it longhand just so that you can get a good feel for how to do these trinomial factorizations. Doing each trinomial factorizing as working out below the sum, I'm going to do them all, and then lastly, I'm going to take their factors and put them in the correct place back into the sum. So here, if I take a look, I see that my last sign is a minus, which means that when I do my trinomial cross and I add my terms to get the middle number, I must minus. The next thing that I do is I take my two coefficients. 2 times 1 is 2, and 3 times 1 is 3. But where would I write the 3 so that when I minused, I got an answer of 1? Well, the 3 would have to be here at the top, because when I take 2 and 3 and I minus them, I do get a 1. But I don't want just a 1, I want a plus 1. In other words, I have to write the plus 1 with the bigger of the two numbers, and 3 is bigger than 2, so it gets the plus. Filling in my x's, I now know the factorized brackets for the trinomial of 2x squared plus x minus 3. By now you should start to be understanding the method quite nicely. The third one is going to once again be a minus trinomial cross. When I take my coefficients, the 6 is the awkward coefficient because 1 times 3 can only be 3. So I write that one in first, and then I say to myself, well, how am I going to split 6 so that when I minus, I'm going to get a 7? Well, if I write the 3 here, I've got 9, and 9 minus 2 is 7. But I want a plus 7 answer, so I must have a plus 9 minus 2. And fully factorized, this sum is now going to be 2x plus 3 times by 3x minus 1. Moving on to the next one. Once again, over here, I notice that I have a minus trinomial factorization. Filling out the coefficients, 2, which is 2 times 1, and 3, so that I can get an answer of 1, I'm going to fill them out again as I did previously. But this time my answer must be minus 1. As 3 is bigger than 2, the minus goes with 3, and the plus goes with 2 times 1. Filling in the x's and my brackets, I have the next trinomial factorization. And lastly, once again, I must do a minus trinomial. And so filling in the values on my cross, 1 times 3 is 3, and 1 times 2 is 2. But if I write 2 times 1 and I minus these numbers, I get 6 minus 1, which is 5. Not only wanting 5, but minus 5, I must write minus 6 plus 1. And once again, filling in my x's and filling in my brackets, I have now fully factorized all of the trinomial factorization. All that remains is for me to factorize the last denominator, which will be a difference of 2 squares. Completing my difference of 2 squares, my last denominator is going to be x plus 1, x minus 1. Now my whole expression is fully factorized, and what I need to do is I need to change my divide sign to a times sign and tip the fraction that came immediately after. As the first two fractions did not come after a divide sign, I write them down exactly as they were. So the first fraction of 2x minus 3, x minus 2, all over 2x plus 3, x minus 1 remains unchanged. As does the next fraction, because the sign prefixing it is a times, and you do not change your fraction to its reciprocal if it is prefixed by a times. But in the last fraction, it had a divide before it. So you change the divide to a times and you tip the fraction after. In other words, the denominator gets written in the numerator and the numerator gets written in the denominator. Now the saying goes, tip and times, but that's never really made much sense to me because you're going to first do times and then you're going to tip the fraction after. So try and remember times and tip, and then you will understand the order of the instruction that you need to follow. Now what remains is for me to cancel common factors. If I cancel common factors, I must find one factor in a numerator which matches the same in a denominator, or one in a denominator which matches the same in the numerator. Notice that you cannot, for example, cancel 3x minus 1 with 3x plus 1 because they do not have the same signs. But all of the other factors have a factor that matches one from the numerator and one from the denominator. So your answer is going to be 3x minus 1 all over 3x plus 1.